Hi 107 folks, so this is lab one. This is our PowerPoint, but a video kind of overviewing it again for those of you that might want to hear things again. So this particular week we're working on the metric system and measurement. And metric system is something that is used internationally, but most commonly used worldwide. We do not use it very often as our system in the United States of measuring. However, we do see this in our society for sure, how we measure things and how things are kind of recorded. Metric system is also referred to as the International System of Units. And for the most part, it's very foreign to us. However, it is a very simplistic system because it's based on 10, a decimal system of 10. And when we think about that in math, we move a decimal point, we're moving it basically tens. And so basically, we're talking about a decimal system and where we're moving the decimal point to the left or the right in the number, depending on what we're converting and what we're kind of moving to. So when we think about the metric system, we think about these are the things that we might look at. We might look at the length of something, the mass, the weight, volume, density, and temperature. So most commonly in our particular class, we're going to worry about length, mass, volume, and then temperature. We don't spend so much time on the weight per se or the density, but we'll talk about them. Now, if we're looking at the length of something, the metric unit, the basic unit that we would talk about is what we call, we would use a meter stick and we'd call that a meter. So not a ruler, okay, but a meter stick. So most of you probably have some type of ruler in your house, but or you might have a yardstick, but we would, in our science class, would call this a metric, a meter stick, or a centimeter ruler. We might have inches on one side, but you would have metric, centimeters, and millimeters on the other side. Mass, okay, how much something actually takes up as far as space is concerned, we would look at this, okay, the mass of something. And we'd weigh that in grams, most likely. And we would use, this is what we call a triple beam balance, which is something we would use in class. The weight of something is a little bit different on how it's actually, not necessarily what it consumes, but a little bit different. So we use a spring scale here. Volume is usually measuring something that is liquid. So usually we have some type of liquid within a container. Most often times in science, it is a piece of glassware that is graduated, which means that it has all these kind of little numbers on it so we can actually measure an actual unit of it. This is a graduated cylinder, but we could use a beaker or a flask or a test tube that's graduated. And that is volume, and volume is usually measured in liters. That's our base unit. Now, density has to do with, here we have oil and water and sand. It's basically our mass over our volume. So this number we might have over this number is what we consider our density. And that is, again, putting something into a liquid scenario. In this case, the density of oil, it sits on top of the water because of the calculation. And there's a few other factors why oil and water don't mix, which we will get to in a few chapters. But sand are tiny little particles and they have a higher density, so therefore they're going to sit at the bottom of this kind of, let's say, test tube. Okay, and the last thing we would see and we would use in class as well is temperature. Now, temperature is either measured in Fahrenheit or Celsius, and Celsius is what we would measure in metric. We use Celsius in the healthcare field all the time and in the science field. So those of you that work in healthcare probably do take temperatures or hear temperatures in the Celsius, whereas in common layman's way, we would think of Fahrenheit. However, in our class, we will be looking at Celsius temperatures. And obviously, we can use lots of different types of thermometers for that. So again, here's just a breakdown of the three main, because they're a little different than temperature. We have volume, which is measuring some type of liquid usually. Our base unit here is liters. We might use something like a graduated cylinder. Mass is measured in grams, and again, here we might use an example of that triple beam balance, like I stated. And length, its base unit is meter, and we would use a meter stick to measure. So here again, just another visual. Here's our measurements that we're primarily focused on: mass, length, volume, and temperature. Here are the base units: gram, meter, liter, degrees Celsius, and therefore here are our symbols. A mass, gram, is basically just G. A lengths meter is M. Volumes liter is L. Meter, liter? I'm sorry if I messed that up. But those are our bases. Now, what we like to do is we have metric prefixes. Now, when we think of what a prefix is, think about English class. A prefix is a word that comes in front of another word that is descriptive. It tells us something. So in this case, we can put prefixes in front of those base units. So we can put a prefix in front of gram, meter, and liter. And when we do that, we change the word, we change what it means. So maybe you've heard of a kilogram. Maybe you've heard of a kilometer or kilometer. Maybe you've heard of a milliliter. So all these are little words in front of our base unit word are what we call prefixes. So if we kind of look right here, let me get my pen out for a minute. This is kind of where our unit would be, whether we were doing, well, excuse me, whether we were doing liters, meters, or grams. And if you look up here, this is kind of going upward, right? These are some prefixes that we might see. So if we're going up this kind of area here, and we're looking at these structures, there's some prefixes, deca, hecto, which are maybe not as common for you. Kilo, mega are more common we might hear, but you might also hear giga and tera nowadays with technology. If we're kind of going down this table, okay, again, remember this is our unit right here, liter, meter, and gram. We have other prefixes, deci, centi, milli, micro, nano, picto, so these are more common. We probably hear these more often than not. What I don't want you to kind of panic about is this part. So like, don't look at the explanation. Don't even look at kind of the notation, because some students just get so frustrated with that they're like, wait, this doesn't make sense. Let me show you how this is simply going to work. Here, these are prefixes. These will help you. So obviously a little k is kilo, a big M is mega. So this is micro. Micro is kind of this fancy U. Like if you're making a cursive U with nothing else attached to it. Milli is little m. So again, you have big M, little m's. And so you just need to make sure you're looking at the right structure here as far as what it looks like. But let's look at this. This might be a little bit more helpful. Don't again get bogged down that there's so many words here. This is an acronym, so it helps you. King Henry died unusually drinking chocolate milk. Okay, so it's just a funny acronym, and it helps represent where things come. So King represents kilo, Henry represents hecto, died is deca. Remember, these were on the top part of that previous graph. Unusually is our unit, so that's liter, gram, or meter. Drinking on this side is deci, chocolate is centi, and milk is milli. And these are the most common ones we see. Don't think that there aren't others, obviously, like I showed you on the previous table, but these are the most common prefixes that we are going to use. So when we want to make conversions, we need to kind of look at the chart. First of all, we need to know what unit are we starting with? What does that look like? And then what is our conversion unit? So for example, let me get my pen again here. Let's say that we're looking at like 5, okay, and we have grams. Whoa, that was really bad writing. Okay, and we want to convert that to kilograms, let's say, because that might be something we hear often, kilograms. Okay, so kg. So first of all, I have 5. Now, where's the decimal point at this 5? It's a whole number, and if you think back to math classes, math always tells us if there is not a decimal point, our assumption is that the decimal point is at the end of the number. So it would be 5 points. That's our decimal point. Now, grams, okay, is our unit here, right? So this would be our unit here. But we want to move to kilograms. So we're moving from gram to kilogram. So what we kind of need to do is we need to like do this like old-fashioned kind of math bunny hop. This is not new math by any means. We're going to go 1 spot, 2 spot, 3 spots. So I have to move my decimal point, first of all, 3 spots. And when I move it 3 spots, what actually is happening is that we are moving the decimal point to the left. So anytime I'm moving this direction with my conversion to the left, I'm moving my decimal point, exactly that way. And I just lost everything I typed. So let's try this again. So we have 5 point grams equaling my kilograms. So if I did this, all right, I have 5 and I'm going to move kilograms. I'm going to go 1, 2, 3, and I actually have to add some zeros. There's my decimal point. I have to add 2 zeros. Oh my goodness, I'm sorry. I'm struggling writing on this tablet today. All right, so it'd be 0.005 kilograms. Well, the number got smaller because our prefix made our unit get bigger. Okay, now the opposite of this is that I would actually could do the same thing and move the other direction. So let's say in this example, I have a liter. Maybe I say I have 10 liters. My decimal point's at the end because it's a whole number. And I want to go all the way down here to milli and make this into milliliters, because milliliters we actually hear often in our society, especially again in the healthcare field and the science field. So what happens again here is this chart shows me how many I have to actually move. Sometimes there's other prefixes in between and that can be confusing, but here I'm going to go 1, 2, 3 again. And when I do that, I'm actually going to have to add some zeros again, but I'm going in the other direction. At this point, if I'm going to the right, I am going to the right with my decimal point. So here, 1, 2, 3. So what I'm going to actually have for a number is I would have a decimal point here, and I would have to add 1, 2, 3 zeros. So 1, that's what our original number here. Whoa, sorry, this is horribly. Looks like I write like a kindergartner. Okay, so 10,000 would be the actual equivalent to that. So this is what you need to practice. There's a few things in your lab assignment this week to practice conversions. Now, I just came from this unit, obviously. However, you could come from here and go to here. You could do any of these kind of conversions. What you need to remember, the dividing and multiplying can be challenging because just those words scare people. What you need to remember is if you are going to the left, like if you were on this chart and you're going up here to the top, you're moving to the left. If you're going down this way, you're moving to the right. So it's always a matter of looking at what is my prefix that I'm starting with, if there is one, whatever the unit is, and then where am I going to. Now, converting for temperature is different. We actually use a calculation here. So if we have our Fahrenheit and we are going to convert it to Celsius, basically this is the way we need to do this. And you do need to remember this, kind of ingrain it in your head a little bit. So if we know the temperature outside is 100 degrees Fahrenheit and we wanted to convert that to Celsius, what we're going to do is we're going to take 100 minus, subtract 32. If you're using your calculator or your phone, you might have to equal, obviously, and then from there you're going to multiply it by 5, and then you're going to divide it by 9, and that should give you your Celsius degrees. So if you tried real quick, I said put the example of 100 in, so 100 minus 32 will give me 68, but I'm not done yet. I need to take that 68 and then multiply it by 5, and I get 340, and then I need to divide by 9. So what I get is about 37.778 blah, blah, blah. Okay, remainder. So about 38 degrees Celsius is equivalent to 100 degrees Fahrenheit. If you wanted to flip it the other way and figure out Celsius to Fahrenheit, you just invert everything. So what you're doing is taking your Celsius, multiplying it by 9, then dividing by 5, and then adding 32. So take a few minutes to actually practice that with one of another example. So let's say if we think about just a random number, let's try 25 degrees Celsius and see what that actually converts to. So if I take 25 and I multiply it by 9, I get 225, and then I divide it by 5, I get 45, and then I add 32, it's 80. So if I was 25 degrees Celsius, then it would actually be 80 degrees Fahrenheit. So Canadian, I'm in Canada, use this, and obviously that's their temperature that they always use is Celsius versus Fahrenheit, and other countries do as well, so that might be interesting if you're traveling. However, the healthcare field and the science field also use these in the United States. So that's about all I have for metric this week and measurement. You're going to be practicing with your lab exercises, converting and measuring and collecting data. All right, thanks folks.